In this video, I'm going to talk about alternating current and light-emitting diodes and the issues that can arise when you use them in combination. So, several years ago, they came out with these LED string lights, which were made to replace the tungsten filament string lights. Now, that's a good idea, because not only do LEDs last longer, they're also much more efficient. They use less power. And it isn't going to be noticeable on the camera, but these things flicker at a really obnoxious frequency. So I'll use a photo resistor to illustrate that. Okay, so here's the LED on time. It's off approximately half the time. And if we overlay this with an AC waveform of the same frequency, so you can see that when they overlap, only 50% of the energy is being put out as light. And at the other 50%, it's really not being utilized. So let's see if we can improve the light output of the LED circuit. Okay, so here is the LED string light circuit. This diode here represents 35 diodes placed in series. So their collective forward voltage is between 84 volts and 120 volts. Their current is 30 milliamps, and their peak inverse voltage or reverse voltage is 175 volts. And since the LEDs are only on during the positive alternation of the 120 volts, what I'm going to do is rectify the 120 volt signal, so instead of being a sinusoid, it's going to be pulsating DC. So something like this. And the way I would do that is by using a bridge rectifier, which consists of 4 diodes. So here's the bridge rectifier. Here's your hot and here's your neutral from your wall outlet. And instead of outputting the sinusoidal waveform, it outputs the pulsating DC waveform. And here's the circuit I'm going to make. So here's the bridge rectifier. So here's the positive voltage off that, and here's the negative voltage off that. And I have a capacitor placed from the positive to the negative, and that's just to stabilize the pulsating DC. So instead of having a signal that oscillates like this, it's going to be just more of a stable waveform, like so. So it doesn't reach the 0 point again. And I also put this resistor in here. And this resistor is here to drop part of that voltage from the capacitor. This capacitor is stored up to roughly 170 volts, and these LEDs are only rated for 120 volts. So this resistor is going to be dropping 50 volts. Alright, let's build it. Okay, so at this point all I have is the bridge rectifier and the resistor. I've left the capacitor out just to illustrate the ripple effect without it. So if I come over here and view my oscilloscope, presently that ripple is from the fluorescent lights overhead. So if I cover it and turn on the LEDs, you can see the ripple. And there is the ripple without the capacitor. So if I put a 60 Hz waveform next to it, so here it is with the 60 Hz waveform. So you can see that the LEDs are on for both the positive and the negative. So here's the on time of the LEDs. So you can see it's on during the positive and negative alternation of the 60 Hz waveform. Alright, now I'm going to add the capacitor to show you the stability gain with having that capacitor. Okay, so I've added the capacitor. Negative goes to the negative, positive to the positive. And now if we look at that ripple, you can see that the ripple's nearly non-existent. Now I can increase, alright. So now you can see that ripple is nearly non-existent. There's a slight ripple there. Now if I increase the volts per division, you can see it a bit clearer. But that's at 5 millivolts, and previously I was measuring at 100 millivolts per division. So that gives you some idea of scale regarding the ripple. Alright, well thanks for watching, and if you want to build this yourself, please be careful because this is 120.